Hi everyone, in today's video I will be going over the Quarter 3 Benchmark Review Study Guide. There are a few problems that I'm going to skip over, otherwise I will be doing the entire thing. So, number 1, state the number of real zeros for the functions whose graph is shown. So, we specify real because when we look at the graph we can see where the graph actually crosses the x-axis, and that's what tells us where there's a zero. Whereas if we have just an equation, like in 2a here, for instance, just to show the comparison, we'll find the maximum number of zeros, but that doesn't mean that's how many zeros there actually are. So we can get those from a graph. So looking at our first graph here, you count how many times the graph hits the x-axis. So we've got 1, 2, 3, and this does count 4. We haven't gone into this level of detail, but a line, when it hits the x-axis, it can either go straight through it, or it comes up, touches it, and then goes back down, or goes back up. It's called bouncing off the x-axis, so it either goes through or bounces. We'll look more into that later. So this graph has 4 zeros. B, we've got 1, 2, 3 zeros. C, it doesn't cross at all, so this would be 0 or none. And then this graph D has 4 zeros as well. Number 2, as you can see, I'm going to skip letter B. Letter B, it's just more of a thought exercise than anything. This will make sense in a later unit, but right now I think a lot of you would get tripped up on it, so I'm not going to discuss it at this point in time. What is the maximum number of possible zeros for the following functions? So again, this is a maximum number of possible zeros, meaning it's how many it could have, but we don't know without either doing the math to find them or graphing them. So we are just making assumptions here. The maximum number of possible zeros is the same as the degree, the highest exponent. So when you're doing these, I didn't do this first and foremost, but make sure that this is in standard form before you just answer the question. C, h of x equals 2x to the fourth minus 2x cubed plus 2x squared minus 6x minus 12. It's in standard form, so we can go with the first exponent, which is 4. And D, negative 3x squared minus 2x plus 7x to the fifth plus 43. This is clearly not in standard form. The exponents are not in order, so we go with the highest exponent, which is 5. All right, number 3. As you can see, I'm going to skip the graphing portion. It's not necessary for this study guide. Find the inverse of the function f of x equals 6x minus 4. So you remember this was a 4-step process, and I will write them out on this problem only, and then the next few I will just follow the steps. So the first step is to rewrite f of x as y. Step 2, and this is called the inverse step. It's what an inverse is. You switch x and y. Step 3, you solve for y. And then step 4, rewrite as, and then it just depends on your letter. So in this equation, we are given f of x, so we rewrite it as f inverse of x. Remember, that's what the symbol means. With the -1, it's f inverse of x, or inverse f of x. Say it either way. So these are the 4 steps I'm going to follow as I solve. So step 1, I'm going to rewrite that f of x as just y equals 6x minus 4. Then you switch x and y. You only change x and y. You don't take any numbers or symbols with them. So where you have the y, you write an x. Where you have the x, you write a y. That is the only thing you're changing. Then, so that was step 2. Then from here you solve for y, get y by itself. So I'm going to rewrite this. We're getting y by itself. X is already by itself. We need to get y by itself. Add 4 over. And then remember, you can't actually do x plus 4. You just can't add them, they're not like terms. So it's x plus 4 equals 6y. And then lastly, we need to get the 6 off of the y, so I'm going to divide both sides by the 6. That cancels out. And then in this next step, I'm going to rewrite this, but I'm going to flip these sides because we're used to seeing y equals on the left side. And then I'm going to write that on the right side. And it is perfectly fine to leave it like this. In fact, I wouldn't try to separate it in case you make a mistake and get a wrong answer. You would separate it for graphing purposes, but it's not needed for this video, so I'm not going to bother with it. And then step 4, we rewrite the y as f inverse of x. So this was f of x, and this is where some more space would come in handy. So I'm going to switch back to my marker so I can show this better. F inverse of x equals, and then your answer, what you got, x plus 4 over 6. So that is your final answer. All right, so that was one inverse problem. Once again, I'm going to follow the steps. I'll number, but I won't fully rewrite them, obviously, one more time. So we have step 1. Rewrite f of x as y. So we have y equals 6/5 x minus 2. And then the next step is to switch the x and the y. So we have x equals 6/5 y minus 2. And then step 3, you start solving. So I just rewrite this to get myself started. So again, get the y by itself. Add 2 to both sides. Again, do not actually add them. You can't add x plus 2. It's not 2x. Bring down 6/5 y. And then how you remove a fraction from a variable. You have to multiply by the reciprocal. So, I'm going to do that times 5/6. And then I'm running out of room over here, so I'm going to need more space in a moment. So that's going to cancel each other out. I'm going to come over here. This is going to be y equals, again, I'm flipping the equation around as well when I do this step. And then this, we have 5/6 on the outside times x plus 2. And this is the proper way to write it. If you drop these parentheses, it is incorrect because it's all of this times 5/6, not just the x. So use those parentheses and then just leave it out. You can distribute this in there if you want, but that's just more work for you. There's nothing wrong with having that as your answer. The last step is to rewrite it, and it depends on your letter. We still have an f here, so f inverse of x is still the right way to write it. So f inverse of x instead of y equals 5/6 times x plus 2. Final answer. Another one, number 5. Find the inverse of g of x equals negative 2x plus 9. So first step is rewrite this as y equals negative 2x plus 9. Step 2, you switch the x and the y. So this becomes x equals negative 2y plus 9. Step 3, you solve for y. So we subtract 9 on both sides first. We have x minus 9 equals negative 2y. And then we divide by negative 2 on both sides. And then again, I'm doing a switch here, flipping the sides. Y equals x minus 9 over negative 2. And then the last step is to switch it back in terms of your letter, which in this case is a g. So that's going to become step 4. G inverse of x equals x minus 9 over negative 2. Had to get a little squish there. So, make sure you switch it back to inverse g at the end there. It's the same equation, just switch the y back into terms of g. All right, next page. We've got two more inverse problems. One of them is going to be very easy if you remember how to do it. Number 6, find the inverse of the function h of x equals x squared minus 36. Once again, I'm going to use the same steps as the front side. Change h of x to a y. Y equals x squared minus 36. Step 2 is the inverse step. You switch the x and the y. Again, that squared does not go with the x. It stays there. It's now going to be y squared minus 36. And then we can start solving. X equals y squared minus 36. We're solving again for y. Add over that 36. We have x plus 36 equals y squared. And then hopefully you remember how to get rid of a square. You take the square root of both sides. And then remember, when you take the square root, so we're square rooting the y, it's just going to become y. The other side also gains a symbol. It is the plus or minus symbol. You do have to include that for your answer to be correct. Once again, I'm going to switch the sides here as I do this. So this will be y on the left equals plus or minus the square root of x plus 36. And then last but not least, step number 4, change the h, change it back in terms of h. So it's h inverse of x equals, and then your equation, plus or minus the square root of x plus 36. And there you have it. Number 7. Find the inverse of the function k of x equals negative 6, 2, negative 1, 0, 22, negative 9, 1, 3. So a lot of you look at this and you get extremely confused, but the concept is still the same. When you take an inverse, that means you switch x and y. That's why I call step 2 in the equation solving process the inverse step, because that's where we switch x and y. So that is what taking an inverse means. At the very basic level, you are switching x and y, whether that's in an equation, on a graph, or on the points. So we're doing the same kind of idea here. Leave this as k of x, but do change that to the inverse of k, because we are finding the inverse of k. Equals, this is a nice little curly bracket. And then all you're doing, because each point is x, y, you're just going to switch them. Switch the numbers. So instead of negative 6, 2, it is 2, negative 6. 0, negative 1. Negative 9, 22. And 3, 1. And that is it. There you have it. All right, getting away from inverses and back to some of the more recent material. Match each of the following graphs with its polynomial function. So here we have 6 graphs and 6 equations. Each graph matches to an equation. And this looks difficult, but actually there is a very neat kind of cheat to answer this question. Now, most of you are going to look at this and you'll understand that you're supposed to look at in behavior, but you're going to quickly run into issues with that because, let me find a couple examples. You have, let's look at h of x and m of x, for instance. So these two side by side. They both have even exponent and they're both negative. So they are going to have the exact same end behavior. So narrowing it down is actually going to be a bit harder if you try to go that way. What you actually need to pay attention to is the y-intercepts. All 6 polynomial equations have different y-intercepts. So you can use just the y-intercept to answer this question. So let's look at f of x. Its y-intercept, and remember that's the constant at the end, is negative 12. So we look for the graph that has a negative 12 y-intercept. And if this isn't quite the fastest way, you can go through, point out the y-intercepts on all the graphs, and then just match them. So actually that's what I'm going to do. So A crosses the y-axis at 6. B crosses the y-axis at, that was hard to read, that's negative 12. So actually this is B, what I was just looking for a moment ago. C crosses the y-axis at 4. D crosses the y-axis at negative 4. E crosses the y-axis at 0. And F crosses the y-axis at 3. So now let's find the 5 remaining matches. H of x crosses at positive 4, so that is option C. N crosses at positive 6, which is A. G crosses at positive 3, which is F. M crosses at negative 4, which is D. Meaning P has to match with E. And some of you may have struggled with this a bit, because if you look at this, negative 4 is not the y-intercept. Negative 4 is attached to an x. Remember, the y-intercept is a constant. Like the other 5 numbers, it is just a number, no x on it. So its y-intercept is actually 0, because it's not there, so it's a 0. So that would make a bit more sense now. All right. Here we are at composition of functions. You may remember this as the Fogg and Goff functions. So basically this means we are plugging one function into another. So there are a couple ways to look at this. I'm going to try to break it down into what I think is the easiest to follow way as possible. So number 9. If f of x equals x squared plus 5 and g of x equals x minus 4, find g of f of x. So you can see that f is inside and g is outside. So what I like to do is I like to rewrite the problem, g of f of x. And first, let's just look at the inside function. I'm going to work inside out. F of x is equal to, and then this is where you got to pay very close attention to what you're writing down. F of x here is x squared plus 5. And then I'm going to bring the g underneath it. G of x equals x minus 4. Now, what this means, if you remember, we're going to plug the entire f function into the g function. So we're taking all of this, and notice that f is in the x's spot here. So that means that we're going to put all of this into the x in g's function. So this x right here, that's where it's going to go, all in there. And also to help, and this is going to be a big thing on the next problem, go ahead and block off where it's going in parentheses. So now when I rewrite it, instead of x, I have x squared plus 5. And then rewrite the rest of the function, minus 4. Now this x here in particular is gone. It was replaced by x squared plus 5. So now I have x squared plus 5 minus 4. From here, you do need to simplify. You can't just leave this as your answer. We won't be able to simplify much at all, but whatever you can, do it. So x squared plus 5 minus 4, there's no exponents out here or any negatives I have to worry about, so I can drop those parentheses. X squared plus 5 minus 4. And then hopefully you notice I have like terms here, 5 minus 4. That will give me a positive 1. So now it's x squared plus 1. And there's actually nothing else you can do here. So this is our final answer. I'm actually going to switch over to green for my answer boxes just to not cause confusion. There we go. All right. Repeat that process on number 10. This one's going to be a little more involved. If f of x equals x squared plus 5 and g of x equals x minus 4, find f of g of x. So, I'm going to start by just writing out f of g of x. If you're already kind of looking at this, that means we're plugging g into f. So start with the inside function. You work inside out. G of x is equal to x minus 4. I'm going to put f underneath it. F of x equals, oh, it's the same functions, x squared plus 5. So now we're going the other direction. This time, we're plugging all of g into f. That's what this notation is telling us. And this g is in the x's spot up here. So that means wherever f has an x, we're going to replace it with all of g. So basically, all of this is going into the x for f, which is right here. Now this is where parentheses are important. That squared is not included in here. It's left on the outside of those parentheses. If you do this as an x squared, that's going to completely change your answer. It goes outside. So all of that is going to go in here. So now let's write out our new function. And not x minus 4. Then bring the rest of the function down. Squared. So the squared goes out here, not on the x. Plus 5. Now, unfortunately, if you leave your answer like this, you will lose credit. This is not what we're looking for. It's not fully simplified. There's some stuff you could do here. Right off the bat, this squared does not get distributed inside of those parentheses. That is not how that squared works. Remember, when you square a number, that means you're multiplying it by itself. So, just as a reminder, if you have 3 squared, that means 3 times 3. You're multiplying it by itself twice. If you have 3 cubed, that means 3 times 3 times 3. So when you have a binomial, like x minus 4 squared, that means it is being multiplied by itself twice. And you already know that if you just distribute that squared, you will not get the same answer as if you fully FOIL this. I think we can all agree on that. So, take the extra step to think about that. Write this twice. X minus 4 times x minus 4 plus 5 out here. And then this is nothing new. You FOIL and then combine like terms. So, x times x, that is x squared. X times negative 4, that's negative 4x. Then we're distributing this negative 4 through. Negative 4 times x, that's another negative 4x. And then negative 4 times negative 4, that's a positive 16. And don't forget to bring down the plus 5. If you don't, you will not get the correct answer. All right, from here, the only thing we can do is combine like terms. So I have negative 4x and negative 4x. This will make a negative 8x. And then I have a 16 and a 5. Just add them together, and you will get 21. And that is my final answer. Now we're going to do a similar idea, but with numbers plugged in. Number 11. If f of x equals 2x minus 7 and g of x equals 3x plus 6, find f of g of negative 4. So just like before, I'm going to start with f of g of negative 4. Start with the problem. So first we're going to work with the g of negative 4. So a reminder of what this means. The g function is 3x plus 6. And this g of negative 4 is telling you that that is your x value. So where I have the x, I actually need to put a negative 4 in its place. So I'm going to erase the x, and then in parentheses write, need to make more space here, -4. So that's what that means. And then I just do the math, get my answer. 3 times -4, that's -12, plus 6 is -6. And then what I do from here, I'm going to drop this f down. Now, instead of g of -4, I now know that actually equals -6. So I'm going to drop that -6 inside of those parentheses. And now this is a similar question, but with the f function. F equals 2x minus 7. Once again, that -6 in there means that's what the x is. So I'm going to replace the x with -6. And I'm running out of space here, so I'm going to have to go a little horizontally. 2 times -6 is -12 minus 7, and that gives us -19. And there's nowhere else to go with this. I have answered the question, so -19 is my complete answer. Let's do that one more time in number 12. Same process. I'm going to block this off just in case. If f of x equals x squared minus 2x plus 1 and g of x equals 5x plus 2, find g of f of -2. So I'm going to write that down. So first I start with the f of -2. So write out the f function, x squared minus 2x plus 1. Once again, that number in parentheses means that is your x value. So you have to pay extra close attention. I'm sure some of you are already catching on to this. I've got more than one x. Yes, every single x here gets a -2. So I don't just put it into the first one. So both of these x's are going to get erased. And then in parentheses, I'm going to write -2. From here. Now, I know a lot of you rely on the calculator, so I'm going to make a big deal about this right now. -2 squared is not -4. Just so we're on the same page. Yes, you can type -2 squared into your calculator, and you'll get -4. That is not correct, and it's not the calculator's fault. So it's how it reads what you typed in. It reads what that is as negative on the outside 2 squared. So that means it's going to get the 2 squared, which is 4, and then it's going to keep that negative. You don't want that. It's not going to read it correctly. What you want is in parentheses -2 squared, because that reads it as -2 times -2, which is positive 4. There is a big difference there. So do not forget those parentheses if you use a calculator. That is why I am always stressing parentheses. So if I come back up and do -2 squared, I will get the correct answer of 4. So that is very, very important. I actually remember on this test a lot of you missed this particular type of question because you put that was a -4 instead of a positive 4, and it obviously affected the rest of the problem. So we have 4 minus 2 times -2. Do take the signs into account here. -2 times -2, once again, is positive 4 plus 1. And then 4 plus 4 is 8 plus 1 is a 9. So we found the inside part first. So now I'm going to bring this g down. And I have g of, bring that 9 over and drop it into the parentheses, g of 9 equals, the g function is 5x plus 2. Once again, that 9 in parentheses is your x value. So I'm going to come over here and erase the x and put a 9 in its spot. Five times 9, that's 45, plus 2, that gives us 47. and I have finished out all of my calculations, so I'm done there. Obviously, you don't have to go through, write it out, and erase. Obviously, you can just go straight into plugging it in if that's what makes sense to you. But for those of you who need the extra step, feel free to do it that way. Number 13, now we're into solving equations that involve radicals. Solve the equation, the square root of 3x plus 2 equals the square root of 6x minus 8. So hopefully you remember that the opposite of square rooting is squaring. So I'm going to square both of these. And what's nice is this cancels out across the board. So this square cancels out the radical, and this square also cancels out the radical. So we're left with what's underneath. 3x plus 2 equals 6x minus 8. And then we just solve. So when you have two different x's, you want to get it down to one x term. So I'm going to move the smaller one. So I'm going to subtract negative 3x on both sides. 2 equals 6x minus 3x. That is 3x minus 8. Now I'm going to add the 8 over to the other side and get 10 equals 3x. And lastly, divide by 3. So x equals 10/3. Not pretty, but that is my answer. I wouldn't change that one into a decimal only because this is, I believe it's 3.33, just 3.3 repeating. It goes on forever. So would not recommend as a decimal. Keep it as a fraction. Nothing wrong with that. Number 14. Solve the equation 8x plus 3 to the 1/3 power plus 24 equals 0. This one you want to be extra careful on. This type of problem was one of the most missed on that test when we did take it. I'll get to where the big mistake was when I get there in a moment. First thing you want to do, and I want to emphasize as we're going through this, the goal is to get the exponent part by itself. So this is what we need to get by itself. So first thing we'll do is subtract the 24 on both sides. Bring this down. 8 times x plus 3 to the 1/3 power equals negative 24. Once again, we're trying to get this part in parentheses with the exponent by itself. Here were the two biggest mistakes I saw on the test. Well, actually, let me first tell you what you're supposed to do. You're supposed to divide by 8 first. That would be my next step, and I'm about to do that. The two biggest mistakes I saw. One, people would distribute that 8 into parentheses. You cannot distribute into parentheses when you have an exponent on those parentheses, so that's why you're not allowed to do it. The other thing I saw is people would get rid of the exponent at this step instead of the next step when you're supposed to. And that is something you are allowed to do, but there is a very correct way to do it, and we have not talked about that in class. So, since we've not shown you how to do that correctly, do not do that. Solve this like a normal equation. Subtract or add or subtract the constant over and then divide off what is being multiplied. We do that on a very regular basis. So, next step, divide by 8. Now we have x plus 3 to the 1/3 power equals negative 24 divided by 8 is negative 3. Couple more steps here. Now we can get rid of the exponent. So this is a 1/3 power, and I'm actually going to bring this down while I'm talking because I need a little more space just to really demonstrate. That's more comfortable. Okay, to get rid of a fractional exponent, you're going to raise it to its reciprocal exponent. So the reciprocal of 1/3 is 3/1. Now make sure you do this to both sides. That's another big mistake I saw. Students would do this step correctly, but would only do it to the left side and not both sides. So this has to be raised to, we'll just write 3. 3 over 1 is 3. Now these will cancel. I'm left with just x plus 3 equals negative 3 cubed. This is negative 3 times itself 3 times. Now 3 cubed is 27. Feel free to use a calculator for that. Since it's negative and it's a cubed, we do end up with a negative 27 as our answer. I will show you this briefly for those of you who aren't sure. Negative 3. And then remember you use the caret because it's bigger than the squared. Cubed. Negative 27. Again, do not forget those parentheses. Since I'm multiplying it 3 times, I can have a negative answer. All right, one last step. Again, we're solving for x. Subtract the 3 to the right side. X equals negative 27 minus 3 is negative 30. Final answer. 2 more of those. Number 15, solve the equation. Square root of 4x plus 3 equals negative 2. So here we have a square root. The way to get rid of that is to square it. Don't forget to do the other side. So the square cancels out with the root, and we're left with 4x plus 3. Negative 2 squared, we've already been over this. This is positive 4. 2 steps to solve. Again, we're just trying to get the x by itself. Subtract 3 on both sides. 4x equals 1. Divide by 4. X is equal to 1/4. Number 16, solve the equation. I'm going to come over here. I didn't give myself enough room last time. X plus 27 cubed equals 512. All right, to get rid of an exponent of 3, you could do this one of 2 ways. So just like with the square, you square root. With the cube, you can cube root. Or you can do the reciprocal exponent. Both ways work. I'm going to do the reciprocal exponent. I feel like that's what most students would do. If you do the cube root option, you can do that as well. So I'm going to raise this to the 1/3 to cancel out with the 3. Again, do this to both sides. It's one of the biggest mistakes I see, is forgetting to do it on both sides. It's the golden rule of algebra. What you do to one side, you do to the other. So 3 over 1 and the 1/3, they're going to cancel. And we're left with x, I could drop the parentheses, I guess. X plus 27 equals, we need our calculator to do that. It's been a minute since you've seen this. So we have 512. To get any exponent we want, you use the caret button. And then remember, with fractions, you have to use parentheses. It will read it differently if you don't. 1 divided by 3 to type out my fraction. Close the parenthesis. And we get our answer of 8. Once again, just to show you that I'm not bluffing, if you take away the parenthesis, it will be wrong. That is not 8. So again, parentheses, parentheses. You can never go wrong with using parentheses in a calculator. All right, we just got one more step. Subtract the 27 on both sides. X equals negative 19. Done with equations, now probability. Number 17, Mr. Jaremchuk has 6 pairs of pants, 10 different t-shirts, 170 pairs of socks, pretty accurate, and 5 pairs of shoes. How many different outfits could he make? First off, just a side note, if you don't know who Mr. Jaremchuk is, he is a teacher here at FC. He's actually in the room 2 down from mine. And he loves to collect socks. So this is a very accurate joke that he is making here. Okay, So remember, with probability, you have a bunch of different types of problems, and this is the one that we called the FCP type, Fundamental Counting Principle. When you have a bunch of different categories of items, so remember the key thing there was categories. So we have pants, shirts, socks, and shoes. Different things. You use the FCP rule, which means you can just take those numbers and just multiply them all together, and we get our answer. So our numbers are 6, 10, 170, and 5. Just multiply them. Also, another hint, it does not ask about probability, so there's no fractions involved here. When it asks what is the probability, then we're going to have a fraction. Here they just say how many different outfits can he make. So just multiply them all together. So we have 6 times 10 times 170 times 5. 51,000. And that's it. 18 is an interesting name. Imaginary High School has 15 students that want to be a part of the student council. How many possible ways are there to choose a president, vice president, secretary, treasurer, and class clown? So a couple things. How many possible ways? Possible ways means it's either going to be a permutation or combination. Sorry, computation is something completely different. Permutation or combination. And also it says to choose. Now don't take that like at face value. Choose, select, pick, that kind of thing. Now here is the big hint. President, vice president, secretary, treasurer, and class clown. So we have 15 students. And then we have 1, 2, 3, 4, 5 positions. And there's specific roles here. So again, permutation or combination. This is a dead giveaway of a permutation. And that means that order matters. Yeah. Order matters. So it is a permutation. Once again, if you're not sure about this, you can always make an example. So let me just come up with, we need 5 names. Jimmy, Brad, Jane. I need 2 more. Emma, and Lexi. Okay? And then if I go in this order, that means Jimmy is the president, Brad is the VP, Jane is the secretary, Emma is the treasurer, and then that means Lexi is the class clown. So again, order matters here because if I switch any other spots, if I switch Jimmy and Lexi, now Lexi is the president and Jimmy is the class clown. So order does matter here. It does affect what they do. So this is a permutation. So in your calculator, you need to use the permutation function. And remember, this is 15, choose 5. So you're going to write this, use the P for permutation, 15P5, and then the calculator does the rest of the work. 15, and then in this particular calculator, we go under the probability button, PRB, and then it's the first option, NPR. The second one is NCR, that's for combination, and then 5. 360, 360. Number 19. What is the likelihood, probability, I'm going to pause. When you see that, that means you're going to have fractions, of rolling a number cube in getting a 2 on the first roll, a 3 on the second roll, and an even number on the third roll. So, just want to reiterate, because I saw a lot of mistakes on this kind of problem on the test. So we're talking about a number cube, which is a die, such as this one. If you ever use one of these, you would know, and I'm sure most of you have used one before at some point in your lives. It has 6 numbers, 1 through 6, all around the die. So your options are 1, 2, 3, 4, 5, 6. So when you roll the die, you land on one number. So let's map this out. The probability of rolling and getting a 2. So the probability of 2. Probability of 3. And then an even number. So then the probability of even. So we're going to make 3 fractions. Probability of getting a 2. If you look, there is 1, 2. So it's 1 out of 6. A lot of you would write 2 out of 6. I get why you're writing it. It's just your gut instinct. Not your instinct, but it's like a reflex, if you will. Where you're like, oh, it says 2. I'm going to put 2 over 6. No, the number 2. There is one of them. So you're only going to roll 1, 2, possibly. Then you roll the die again. Probability of getting a 3. Well, it's the same as getting any other number. It's 1 out of 6. And then the probability of even. Look at our list. How many even numbers are there? 2, 4, 6. There are 3 even numbers. From here, you have your fractions. You multiply them. And you multiply straight across. 1 times 1 times 3. That's just 3. Remember, we are multiplying, not adding here, so this is not going to be 18. 6 times 6 times 6. 216. That's it. Now again, if you would like to simplify, that's quite all right. You can do that. Calculator. 3, and then this ABC button, that's a simplifying button. So you write it with a little bracket, and then 216. If it can be simplified, it will simplify for you. 1 over 72. So that is the reduced version. So I'm going to box the 3 out of 216, but you can also write the 1 over 72 and get credit. All right, next page, last page. A lot of you guys really like these problems. You're very good at them. How many females liked football? So we're just looking at this table. This just says how many. Not what's the probability of getting a female that liked football. How many? So you just answer the question, how many females like football? So look at the table. Find the female category and then find how many liked football. 13. That's it. Don't make a fraction out of it. Given that the person is male, that's where you pause, circle it. This is your total. Given that the person is male, how many males are there? 48. What is the probability? Again, probability means fraction, which by the wording of the question, I already knew that's where we were going. It's pretty much a kind of standard. What is the probability that they like baseball? All right, so out of these 48 men, how many like baseball? So let's go over to the baseball category from there, 13. So we're looking only out of this category here. How many of these men like baseball? 13 out of 48. That's it. And then I can't remember if this one simplifies or not, but again, simplifying is completely optional here. I don't think I even tested it earlier. It does not. This one does not simplify. So that is our answer. C, given, this is where we want to pause, given that a person likes basketball, that means that's our total. So of the people who like basketball, so we have basketball, 31 total. What is the probability that they are male? So out of these 31 people, how many of them are male? 15. And that, I can guarantee, does not reduce. Nope. We're good there. One more. Of the people surveyed. So remember, of, the, and given kind of signal the same kind of thing. That tells you what your total is. Of the people surveyed. So of the whole table, that's going to be in the bottom right corner. That's the total of the totals. So out of all 100 people, what is the probability that they are female? So out of all 100, how many of them are female? 52. And that one does simplify, I can guarantee that. Believe it's 27 over 50. Ah. Typed in the wrong thing, give me a sec. Oh, it simplifies even further. 13 out of 25. So you can leave the 52 out of 100, or you can write 13 out of 25 and still be correct. All right. Number 21. State the type of equation based on the table, exponential, linear, or quadratic. Notice it does not say none. So none is not here, so we're not going to use it as an option. All right, let's look at the table, and remember, you pay attention to the y values here. The x values will change by 1 every single time. Y, we have 2, 5, 8, 11, 14, 17, 20, 23. Right off the bat, this is not quadratic. Remember, quadratic looks like a mirroring effect. It looks like a mirror. So now we need to figure out how these numbers are going up. 2 to 5, that's going up by 3. 5 to 8 is also going up by 3. Let's try one more time. 8 to 11 is also going up by 3. This is an adding pattern. Adding means it's linear. B, 8, 5, 4, 5, 8. So right off the bat, the numbers go up and then, go down and then back up. And then on top of that, we do repeat some numbers. 8 is in there twice and 5 is in there twice. 4 is in the middle. So if I circle the 4, got to make sure these numbers mirror each other on both sides, and they do. We have that mirroring effect. Mirror, or you could say reflected numbers. That is quadratic. All right, letter C. 10, 5, 2.5, 1.25, 6.625. Okay, we're going to get into some pretty dicey decimals here. Now, 10 to 5 and 5 to 2.5. You can tell that subtraction-wise, they don't go down the same amount. 10 to 5, that's minus 5. And then 5 to 2.5, that's minus 2.5. If I kept subtracting 5, I would have gotten 0 here. So this has to be division. 10 to 5, that's divided by 2. 5 to 2.5, if you didn't know, 5 divided by 2 is 2.5. And then 2.5 divided by 2 is 1.25. So we're dividing here. So this is division. And then if you also have multiplication, typically we look for multiplication. That means you have exponential, the other type. If you ever struggle with the going down with division, you can always start at the end or any number, and you can go backwards and multiply to go up. 2.5 times 2 is 5, times 2 is 10. That would also work. All right, last 3 problems. And this is the most recent stuff we have done, so this is a good review of Unit 7. Find the remaining factors given one of the factors for the following polynomial. So right off the bat, it says factors. You got to pay attention to that detail. That means x plus 2 here is a factor. So this means a couple things. One, we need r to be 0. We have to have r be 0. Next, when we do synthetic division, this does change to a -2. And when we find our other factors, we don't have to actually solve and set them equal to 0. So I'll go over all those points again as I go. So you do two things here. You use synthetic division, and then you factor your answer. So we have x cubed minus x squared minus 10x minus 8. I'm not missing anything here. So I can set up the synthetic division, change the +2 to a -2. So that's what we're dividing by is -2. Then we write our coefficients. 1, -1, -10, -8. And then we start the synthetic division process. Bring down the 1. And I am going to go ahead and write out the steps for this video. 1 times -2 is -2. And then we add -1 plus -2 is -3. Times -2 is, careful, +6. Plus -10, that's -4. Times -2 is +8, which is what we needed to get a remainder of 0. Reminder, it tells you that we are given a factor. For it to be a factor, that means the remainder must be 0. So if you get through the synthetic division and you don't get 0 here, that means a mistake has been made. All right, so we have confirmed that the remainder is 0, so we can continue. So we need to create the DP, the depressed polynomial, the answer. So let's figure out what these place values are. This here is our remainder. The -4 gets no x, the -3 gets an x, and the 1 gets an x squared. So our depressed polynomial is 1x squared, or just x squared, minus 3x, minus 4, no x on that. All right, next it says find the remaining factors. So we just need the factors. So all we have to do, it's literally in the name, is factor this polynomial. We do not set it equal to 0. Now this one's going to be easy to factor because there's just a 1 in front, no extra number besides 1. So this will factor nicely. We have our x's. And then you can use your ACB chart to help you find those factors. A is 1, C is -4. Multiply that, you still get -4. And then B is -3. All right, so we're looking for factors of -4 that give us -3. 4 has only 2 pairs of factors, 1 in itself, and then 2 and 2. Now we need to get a -3 out of this. 2 and 2 can't give us -3, so I'm going to cross that out. 1 and 4 can give us a 3. And then to get this -4, one of these has to be negative. Since I want a -3, I'm going to put the negative sign on the 4. Because 1 minus 4 is -3. If I put the negative on the 1, I'm going to get a +3. Because 4 minus 1 is +3. I want -3. So it's x plus 1 and x minus 4. And I'm done. That's what it asked for. It said find the remaining factors. Yep, so I'm done. There you go. 23, we're going to repeat that process. The one difference is it mentions zeros, not factors. Given a polynomial and one of its zeros, find all remaining zeros of the function. So how this is going to differ. 1, when I do synthetic division, that is a 0. Meaning you do not change this to a -4. It is +4 that we will divide by. Second, when we get to this step here, after we get our answer, we have to factor and set that equal to 0, so we would solve those binomials as well. So it does have an extra step. All right, let's set up the synthetic division. First off, go through here and make sure you're not missing anything. X cubed, x squared, x, no x, we're good. We are dividing by, again, the +4, do not change the sign. And then our coefficients, 1, -9, 26, -24. Start the synthetic division process by bringing down the 1. 1 times 4 is 4. Add -9 plus 4 is -5. Times 4 is -20. Add 26 plus -20, or 26 minus 20, is just 6. Times 4 is +24, which will cancel out with the -24, giving us 0. Once again, we do need that remainder to equal 0, because a 0 and factor both imply it works, therefore r has to be 0. That's our remainder. 6 gets no x, -5 gets an x, and 1 gets an x squared. From here I create my answer, the depressed polynomial. 1x squared, or just x squared, minus 5x, plus 6, no x on it. And then from here they asked for zeros. So that means I bring this down, x squared minus 5x plus 6, and I set it equal to 0. Zeros means it equals 0. So this means I have to factor it and solve the binomials. So the good news is we have a 1 in front, meaning this is going to be easy to factor once again. Now I'm actually serious when I say this. Be careful with the 5s and the 6. This is actually very easy to mess up. So think through your choices before you write them down. A times C, that's just going to be 6. B is -5. Now, 6 has 2 factors, 1 and 6, or 2 pairs, and 2 and 3. Either of these can give you a 5. So again, this is where I say to be careful. What makes the difference is the 6. The 6 is positive. So how I can get a 5 from the 6 and the 1 is if I have 6 minus 1. But if this is a -1, that times 6 is -6, and I need a positive 6. So that is actually not going to work. 2 and 3 right now would give me positive 5. If I make them both negative, they give me a -5. And then on top of that, -2 times -3 is positive 6. So that is what I needed. X minus 2, x minus 3. All right, from here, they want the zeros. I have it equal to 0. That means I'm not done. So I'm going to split and solve. Set them both equal to 0. So I'm going to add 2 to both sides. X equals 2. And then add 3 to both sides. X equals 3. And I'm done. So these are the other 2 zeros, the remaining zeros, 2 and 3. Last problem, number 24. Simplify, write the depressed polynomial. Is it a factor? Why or why not? So this is basically just synthetic division. So the first half of the past 2 problems. It's written as a nice big fraction to kind of throw you off, but remember, a fraction is still division. So let me rewrite this. X cubed plus 9x squared plus 11x minus 21 divided by x plus 7. First off, go through, make sure you're not missing anything. X cubed, x squared, no x, we're good. On top of that, we look here, this is written as a factor, so we can change this to -7. That means we do switch the sign. So I'm going to set it up, and I'm actually going to come over here to do that just because of space. I know I'll need it. So we're dividing by -7, and then I have 1, 9, 11, -21. Start the process by bringing down the 1. 1 times -7 is negative 7. 9 minus 7 is 2. 2 times negative 7 is negative 14. 11 plus negative 14, 11 minus 14 is negative 3 times negative 7 is, careful, positive 21. And those do cancel and give me 0. So that was my remainder. Negative 3 has no x. 2 gets an x. 1 gets an x squared. So it says write the depressed polynomial. We have 1x squared, so just x squared. 2x, so plus 2x. Minus 3, no x on that. No remainder. So I'm going to pause. I've answered half the question. Is it a factor? Why or why not? So it is referring to x plus 7. Is x plus 7 a factor? Yes, it is. You can tell because the remainder is 0. If r equals 0, that means it is a factor, just like in number 22. We were given that x plus 2 is a factor, so this had to be 0. Same thing. This turned out to be 0, so this is a factor. So we will write, yes, x plus 7 is a factor since r equals 0. And that is sufficient. That answered the question. Because it also said why or why not. So we had to get a reason, give a reason. R equals 0, it is a factor. If it doesn't, then it's not a factor. All right, that is all for this video. If you have any additional questions, feel free to come talk to me in person or email me. Otherwise, I will see you guys later. Have a wonderful day. Bye.